On November the 14th, 2023, Voyager 1 suddenly fell silent, sending back only a meaningless stream of binary data. It seemed the spacecraft, which had ventured beyond the solar system, was lost forever. The cause turned out to be memory failure in its onboard flight data system, FDS, risking permanent loss of communication. However, the team of scientists refused to give up. They made the bold decision to reallocate code to other areas of the probe's memory. This process began on April the 18th, 2024, and came with a great risk. The signal took 22.5 hours to reach Voyager, and it takes the same amount of time for a response. Every attempt was a step into the unknown. Just 2 days later, after months of intense work and anticipation, something incredible happened. Voyager 1 reestablished contact. What extraordinary discoveries did the Voyagers make at the boundary of the solar system? Why did it turn out to be so different from what scientists had imagined? And what was contained in the mysterious signal that Voyager 1 sent after months of eerie silence? The alignment that happens only once every 175 years. In that moment, the gas giants lined up on one side of the solar system, creating a unique opportunity to study them in a single mission. NASA seized this chance. Voyager 1, launched after its twin overtook Voyager 2 thanks to a faster trajectory, reaching speeds of 38,000 miles per hour compared to Voyager 2's 34,360 miles per hour. Just 13 days after launch, it captured an historic photo of Earth and the Moon from a distance of 7.2 million miles, which became the symbol of the start of their grand journey. In 1979, both probes reached Jupiter, revealing its previously unknown rings, discovering 3 new moons, and capturing detailed images of its largest satellites. They confirmed that Ganymede is the largest moon in the solar system, as opposed to Titan, that was previously considered largest. They also discovered that Europa's surface is covered in smooth ice riddled with cracks. It's this data that gave origins to the hypothesis of a subsurface ocean, something we covered in another of our videos. Additionally, the scientists had their first close-up view of Jupiter's Great Red Spot, a centuries-old storm larger than Earth. Jupiter was just the first stage of their grandiose journey. Using its gravity for a speed boost, both probes reached Saturn in 1980 and 1981. This marked a turning point in the Voyager mission. Initially, the mission was planned to last only 4 years to study Jupiter and Saturn, but NASA designed the mission's trajectories to allow for potential exploration of other planets. A key decision was the close approach to Titan, the only moon in the solar system with a dense atmosphere. Ultimately, Voyager 1 was directed toward Titan, sacrificing its ability to continue the journey, while Voyager 2 was sent onwards to Uranus and Neptune. The probes delivered detailed images of Saturn and its rings, revealing that they consist of hundreds of narrow, intricately structured rings. 4 new moons were also discovered. Mimas was of particular interest, notable for being dotted with many craters, including, most notably, the massive Herschel crater, giving the moon a striking resemblance to the Death Star from Star Wars. Titan, however, harbored an unpleasant surprise. Its atmosphere was opaque to visible light, preventing us from uncovering the mysteries of its surface. However, analysis showed that Titan's temperature was close to the triple point, a unique condition where methane behaves similarly to how water does on Earth. After Saturn, the paths of the 2 probes diverged forever. Saturn's gravity significantly accelerated Voyager 1, altering its trajectory and making it the fastest spacecraft in history. Voyager 2, meanwhile, continued its planetary tour, heading for Uranus next. It reached Uranus in January 1986, coming within 50,600 miles of its surface. Scientists were surprised to find that Uranus was vastly different from Jupiter and Saturn. While the gas giants are composed of 90% hydrogen and helium, Uranus contains these elements only in its atmosphere. Beneath lies an ocean of water, ammonia, methane, and hydrogen sulfide, with a core of rock and ice at the planet's center. Later, planets of this type were given the name of an ice giant. Uranus also turned out to be the coldest planet in the solar system, even colder than Neptune. After collecting data on its Uranus mission, Voyager 2 moved on to its final target, Neptune. It reached Neptune in August 1989 and remains the only spacecraft to have visited the 8th and most distant planet in the solar system. On August 25, 1989, Voyager 2 captured the first detailed images of Neptune, completing its grand tour. The planet appeared vividly blue, though later data revealed its true color is closer to teal. While Voyager 2 explored Uranus and Neptune, Voyager 1 could only envy the other spacecraft. After its Saturn mission, the engineers disabled a significant portion of its instruments, only leaving technology for studying the environment data. However, after Voyager 1 had another chance to make history. On February 14, 1990, from a distance of 3.72 billion miles, it captured Earth as a tiny, pale blue dot, just 0.12 pixels in size. This iconic photo, known as the pale blue dot, became the last image ever taken by Voyager 1 before the cameras on both probes were permanently shut down. Next, our cosmic travelers entered a long period of calm, lasting a decade and a half, which was interrupted by an extraordinary event. On August 25, 2012, Voyager 1's instruments recorded a sharp drop in charged particles emanating from the Sun, along with a rise in galactic cosmic rays. This meant that the spacecraft had finally entered interstellar space, leaving the region where the Sun's influence ends and interstellar radiation dominates. The slower-moving Voyager 2 crossed the same boundary in November 2018. The unique bubble of our solar system, called the heliosphere, extends about 11 billion miles from the Sun. It's formed by the solar wind, a stream of particles from the Sun, and ends at the heliopause, which is the boundary between the heliosphere and the interstellar medium. The Voyagers are the only spacecraft to have crossed this boundary and exited the solar system. What they discovered out there sparked widespread interest and active discourse among scientists. Previously, it was believed that the solar wind gradually weakens as you get further from the Sun. However, data from the probes showed that the solar wind doesn't fade, but instead reaches a sharp boundary. Beyond this boundary, its influence ceases, and interstellar space begins. This means the solar wind doesn't simply dissipate, but changes direction, forming a physical boundary between the two environments. The solar wind flows around the heliopause from the inside, while interstellar plasma flows around it from the outside. We were also able to determine the shape of the heliopause. On one side, it resembles a sphere, while on the other, it stretches into a long tail. Curiously, this shape is not static. The boundary of the solar system is constantly moving. The surface of the heliosphere is distorted by massive waves that appear at unexpected, non-uniform angles. These waves can reach 10 astronomical units, equivalent to 10 times the distance between the Earth and the Sun, or about 930 million miles. Additionally, by studying Voyager data, scientists discovered that the heliopause underwent rapid changes over a very short period. This may explain why the time difference for the two probes crossing the heliosphere's boundary was so large, 6 whole years. However, these changes in the movement of the heliopause contradict existing scientific models and remain unexplained. Data from Voyager 1 and Voyager 2 spacecraft also revealed that interstellar space consists of denser, colder plasma, while the plasma near the solar system's boundary is hotter and less dense. Importantly, these two types of plasma interact with each other. Particles from the solar wind and interstellar wind mix, creating a sort of boundary layer between the heliopause and interstellar space. But the interaction between the Sun and interstellar space doesn't end there. Shock waves emitted by the Sun can pass through the heliopause into interstellar space, creating disturbances similar to those caused by supernovae, which generate shock waves spreading through interstellar space. Thanks to the Voyagers, scientists also learned that the interstellar magnetic field is 2 to 3 times more powerful than previously thought. This, in turn, means that interstellar particles exert 10 times more pressure on the heliosphere than expected. The data obtained from this interaction provides a more comprehensive understanding of what occurs between the Sun and interstellar space. These insights can be applied to all stars that are being studied by astronomers, as it's believed that other stellar systems likely share the same properties and processes as our solar system. Throughout their journey through interstellar space, the Voyagers have continued sending signals to Earth, transmitting data about the status of their instruments and their locations. However, in 2022, Voyager 1 unexpectedly transmitted a strange signal. While 14.6 billion miles away from Earth, it began transmitting chaotic data about its position, sequences of zeros or the number 377. This mysterious signal puzzled scientists. The numerical sequence could have either contained critical information or indicated a malfunction. Later, it was discovered to be the latter. The issue was related to the spacecraft's altitude control and maneuvering system. Although it was still possible to control the spacecraft manually, Voyager 1 lost precise awareness of its position, likely due to cosmic radiation affecting its navigation system. NASA engineers successfully resolved the issue by transmitting telemetry through another onboard computer. Another alarming event occurred when Voyager 1 went silent for an extended period starting on November 14, 2023, lasting 5 months. This was caused by corrupted code on one of its chips. To fix the problem, the team made a decision to reallocate the code to other sections of the onboard computer's memory. On April 18, 2024, the process of transferring the data began, which required significant time. After sending the signal, the team had to wait 22.5 hours for it to reach the spacecraft and another 22.5 hours for a response. By April 20th, the team confirmed the success of the operation, and after 5 months, scientists were able to restore communication with Voyager 1 and verify its functionality. These malfunctions remind us that the lives of our cosmic travelers are nearing their end. NASA hopes the Voyager's instruments will function until 2025, after which a phased shutdown will begin. In a few years, the spacecraft will lose the energy needed to communicate with Earth, likely around the 50th anniversary of the mission. This will mark the final chapter of this project. Even after losing contact, these cosmic travelers' journeys will continue. They may witness many fascinating phenomena, though they'll no longer be able to tell us about it. Voyager 1 is moving away from us at a speed of about 3.5 astronomical units per year. 1 astronomical unit is the average distance between the Sun and Earth, approximately 93 million miles or 150 million kilometers. Voyager 1 is currently heading toward the constellation Ophiuchus. In the year 4272, 38,200 years from now, it will approach within 1.7 light-years of a little-known star in the constellation Ursa Minor called AC plus 793888. Its twin, Voyager 2, is leaving the solar system at a speed of about 3.1 astronomical units per year. Around 40,000 years from now, it will approach within about 1.7 light-years of a star named Ross 248, a small star in the constellation Andromeda. Currently, Voyager 1 is approximately 15.5 billion miles away from Earth, while Voyager 2 is 12.4 billion miles away. Although they passed the Sun's heliopause long ago, it's not entirely accurate to say the Voyagers have fully exited the solar system. Scientists believe the solar system encompasses everything within the Sun's gravitational influence. Today, it's hypothesized that the final frontier of this influence is the Oort cloud, a hypothetical spherical region surrounding the solar system, which serves as the source of comets that periodically enter our planetary system. The Oort cloud includes 2 distinct regions, the spherical outer Oort cloud and an inner disc-shaped region. The estimated distance to the outer edge of the Oort cloud from the Sun ranges from 50,000 to 100,000 astronomical units, equivalent to the distance light travels in a year. Voyager 1 will take approximately 300 years to reach the inner edge of the Oort cloud and possibly around 30,000 years to traverse it, marking its ultimate departure from the solar system. If, on their distant journeys, the spacecraft encounter extraterrestrial life, they're equipped with messages prepared by a team of scientists. These include a phonographic record on a gold-plated copper disc. About 3/4 of the recordings are music. The disc also contains greetings in various languages, messages from the US President and UN Secretary General, sounds of Earth, human voices, whale songs, brainwave recordings, and more. It would be plenty for the aliens to occupy themselves. But if the Voyagers are never discovered, they'll continue drifting peacefully through the dark, cold interstellar void. They'll remain a symbol of humanity's quest for knowledge and a reminder to the universe of the ambitions and hopes of the inhabitants of a small, pale blue dot.